Okay, this video is going to be short and sweet because officially it should be a review of things that you've already learned in college algebra. And they're things that maybe we haven't done for a while this semester, but maybe talked about and touched on back at the start. Okay, when we are talking about a complex number, we are talking about the imaginary unit I, where I is a number so that I squared is equal to -1. I is considered the imaginary unit. I'm using the word imaginary because it is not a real number. It's what we use to describe the square root of -1. So we know the square root of 12 is 2 times the square root of 3. If I want to find the square root of -12, then the negative sign gets to come out from under the radical as an I, and we have 2i times the square root of 3. We know the square root of 9 is regular 3, plain old positive 3, but the square root of -9 would be I times 3, or 3i. When we talk about complex numbers are numbers of the form a plus bi, where a and b can be any real number. A number is not in a correct or appropriate form, a correct way to leave it, if we have I squareds in them. If there's any i's on the bottom of a fraction, we have to rewrite and find an equivalent expression that just looks different. So we remember that I squared equals -1 as we're going through. If I want to add two complex numbers, there's an a plus bi, here's another a plus bi. When we're adding complex numbers, it's just the way you would want it to be. We're always going to add like terms when we add and subtract anything in algebra class. So 2 plus -4 is -2, and 3i plus -i is plus 2i. If we're asked to subtract these two numbers instead of adding them, then just as we did anytime we're subtracting an expression, we make sure that negative sign gets distributed to everything it belongs to, and then we combine our like terms from there. Multiplying two complex numbers, we're going to distribute, or we're going to FOIL first. So our first terms, our outside terms, our inside terms, and our last terms. We combine our like terms as we usually do when we're dealing with polynomials or whatever the situation is. But also here, we said we can't leave any I squareds in our final answer. And so we recall that I squared is -1, and -3 times -1 is +3. So +3 and -8, my first terms and last terms can now go together, and I get -5 minus 14i. Lastly, when we're dividing two complex numbers, don't know why I did both negative signs there, but that's what came out when my pen hit the pavement there. We can't leave our fraction in this form. We can't leave any radicals on the bottom of a fraction, and that includes imaginary numbers, no i's as well. So what we're going to do is multiply top and bottom of that fraction by the conjugate. The conjugate means I'm going to change the sign in between. -4 stays -4, but the minus in front of the I turns into a plus. When we distribute here and combine our like terms, our fingers will work. +3i squared is the same as -3. So we get -11 out of that, minus 10i. On the bottom, when we distribute, what we've done here is created a difference of two squares. I'll write it out just in case we're rusty. And notice our outer terms and our inner terms are opposites, and so they go away. And what we're left with is 16 plus 1, which is 17. When you multiply a complex number by its conjugate, you will always get a positive real number. It will always be positive, and it will always be a real number. Now, it's not okay to leave our complex numbers in this form. We always want a plus bi, a plus bi, a plus bi. So, to get full credit, every time you need to split your fraction into two pieces. So we can see that the real part of this number is negative 11 over 17, and the imaginary part is negative 10 over 17. Pretty much if you combine these two pages together and the thoughts from there, you have section 4.1 in your book. Please get a hold of me if it's been too long and you don't remember how this stuff works.